What would have happened if we had not classified the elements? Early humans made the first table of it contained earth, water, air, and fire. Aristotle proposed a fifth element, the quintessence. Centuries later, after the identification of many of the elements, we know now Dalton arranged these elements from light to heavy by weight. Earlier, chemists had started dividing elements into metals and non-metals. About 70 elements were discovered by the 19th century. At present we know more than 111 elements. How do we sort out elements? By appearance? By reactions? By weight? Let us discuss how earlier chemists arranged the elements. In 1829, Johann Dobereiner claimed that certain elements could be grouped together in threes. For example, he arranged lithium, sodium, and potassium as a group. The middle one had properties that were the mean of the properties of the other two elements. When we consider relative atomic mass, the middle one, sodium, has the mean value of 7 and 39 to 23. Calcium, strontium, and barium are a similar triad in which strontium's atomic mass has the mean value. Newland's law states that just as a new musical octave starts at every eighth note, similar properties are exhibited by the eighth element. John Newlands compared the periodic behavior of elements with the musical scale do, re, mi, fa, sol, la, ti, do. Newlands arranged the elements like this: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, and a new start, fluorine, based on atomic weights. Newlands represented beryllium and boron by the symbols Gl and Bo, respectively. Modern chemists have given the symbols Be and B to beryllium and boron, respectively. Since the octave law was proposed before the discovery of noble gases, there was no place allocated for these gases. Newlands failed to explain the behavior of heavier elements such as calcium. His system of classification holds good for the lighter elements. However, periodicity was first explained by Newlands. He showed that properties of elements were related to their atomic masses. Newlands explained how certain elements resembled one another in behavior. Chlorine, bromine, and iodine are violently corrosive and form acids. Lithium, sodium, and potassium combine violently with oxygen or water, and their oxides form caustic aqueous solutions. Newlands listed the elements as symbols, along with their position numbers. He did not give a name to these position numbers. Now, since the establishment of the modern periodic table, we understand that the position number is nothing but the atomic number. On 1st March 1865, Newlands presented his ideas at a lecture at the Chemical Society, a forerunner of the Royal Society of Chemistry. The publication committee humiliated him and rejected his paper, on the grounds that it was purely theoretical and unproven. They made several criticisms, including: there was no space provided for undiscovered elements. 2 elements were placed in one box. Unaware of Newlands' ideas, Mendeleev, a Russian chemist, designed an improved periodic table. It gained acceptance because he left spaces for undiscovered elements. 100 years after the death of Newlands, the Royal Society of Chemistry recognized his discovery of periodic law by placing a blue commemorative plaque on the wall of his birthplace. Note its inscription.